This is the summary, for lesson 5, Introduction to Linear Relationships. And that's exactly what this is. We're starting to look at linear relationships that are not proportional relationships anymore. And so what that means is that there's a start that's other than 0. So for example, with the stacking cups problem, you had that 7 centimeter base of that first cup. So that was 0 cups, and it started at 7 centimeters. And then you added 4/3 of a centimeter for each rim, which is what showed up as you stacked each cup after that. So there was a constant change, or a rate of change, but it did not start at 0, so it was not a proportional relationship. In this example, this graph does not start at 0 either, 0, 0, or the origin. It starts up a little bit. And so it's kind of like giving it a head start. So you haven't done anything, but in this case, you're making some money. So Andre makes $15 per hour babysitting. So before we actually get down to this part, what does that $15 per hour mean? That means that for every hour, so if you go over 1 hour from here to here, he makes $15. So this must be a $15 increase from this point up to this point right here. And then if he works another hour, he makes another $15. And he works another hour, he makes another $15. So $15 per hour. So that is the rate of change. So once again, if he goes from 6 hours to 7 hours, he started at $100 after 6 hours, works 1 more hour, he makes another $15 to $115. 7 to 8 hours, he works 1 more hour, and he's made $130. He's added another $15. So that's the rate of change, and you can get that from this description, $15 per 1 hour per hour. Okay, now down here, notice that he gets paid money before he ever even starts working. So he's being paid to travel to the job. So he's getting $10 just to go to that babysitting job. So that's kind of cool. Hasn't done anything yet. He gets $10. So this is like a head start in his pay. So it's 0 hours. He gets $10. And so thereafter, it's $15 for each hour. So it is a constant rate of change, but it's starting at someplace other than 0, 0. So it is not proportional. So if you double the number of hours that he works, you do not double the amount of pay that he gets. If you triple the number of hours he works, it does not triple the amount of pay. You have to include that $10. All right, so we figured out the rate of change, which is the same, by the way, as the slope. And so just from this description, it's $15 per hour. But let's use a way that we've used in the past. Let's look at a slope triangle. And let's say that he's looking at 2 hours of work in which he got paid $40. And then he goes to 6 hours of work for which he got paid a total of $100. So what is the slope? What's the rate of change given these 2 points on the graph? 6 hours, $100, and 2 hours, $40. And so remember, the first thing you have to do is figure out what's the number of units in the vertical direction, and you're going to compare that to the number of units in the horizontal direction. So the number of units in the vertical direction is this 100 right here minus this 40. It's also the same as minus this 40. So you're going to take this 40 away, and you're going to slide the slope triangle down to the horizontal axis. So that's this right here. 100 minus 40, so if you subtract this 40 right here, this triangle then is going to go up to $60 right to this point as you slide it down. And likewise, the horizontal, the number of units in the horizontal direction is that 6 hours minus the 2 hours. So you have to take this 2 hours away, and it slides the slope triangle to the y-axis. So you're sliding it over this way, or actually we slid it down first, and then you slide it over. So we're getting this point to be at the origin right here, 0, 0. So the number of units in the horizontal direction is going to be this 6 hours minus this 2 hours, And it's the same as this 6 hours minus 2 hours. These two sixes are the same. It just slides over. They just slide over these 2 units. This vertical line right here slides over these 2 units, and this horizontal line slides down these 40. Well, these 2 units are actually equals 40 hours. All right. So the relationship of the number of units in the vertical direction to the number of units in the horizontal direction are these $60, the 60 units, compared to 4 hours. So if you make $60 in 4 hours, if you simplify that, how much do you make? You make $15 per hour. So you get the same thing as you got up here, which you have to. So it's $15 per hour is the rate of change. And so then notice that the amount of money is 15 times the number of hours for each hour worked. So the amount of money for each hour worked is 15 times that number of hours. You have to also include this $10, but the rate of change is that $15 per hour. So it's 15 times the number of hours. So the value of this vertical line right here is 15 times the number of units of this horizontal line. So 4 times 15 equals 60. All right, so let's take a look at this a little bit more and get rid of all that stuff. And let's look at the movement of the slope triangle. And we're going to also look at writing the equations. Even though that's not part of this lesson, it's good to review because it's coming up. You're going to have to write equations for these things. All right, so the first thing that we did is we slid this slope triangle to the left by subtracting 2 units. So if you call this 6 right here x, x minus this 2 is right here, x minus 2. And if we plug in the value of 6 for x, 6 minus 2 equals, this equals 4 units. So this length right here, and we want to get the x and y values in there so we can write the equation. So this number of units along the horizontal direction is x minus 2. So we slid this over those 2 units. And then we slid this slope triangle down 40 units. So it's y minus 40. So if you take this 100 and you subtract 40, call the 100 y, that is y minus 40. So it's sliding this down, so y minus 40. So the number of units in the vertical direction is y minus 40, because you have to take this 40 units away. You're left with this. That's its length. That's the number of units along the slope triangle. And for the number of units in the horizontal direction, you have to take these 2 units away and slide it over here. And what's left are these 4 units. That's the number of units in the horizontal direction, x minus 2. And so once again, it was x minus 2, we slid it over, and y minus 40, we slid it down. So we're going to use that to write the equation. So the relationship of the number of units in the vertical direction is y minus 40 compared to x minus 2. So y minus 40, that's this length right here. It's the red one. It's kind of buried in there. Y minus 40 compared to this x minus 2. That's going to equal the slope. The slope is the number of units in the vertical direction compared to the number of units in the horizontal direction, which is the same as the rate of change. Well, we already know what that number is. We already figured that out. We actually got that from the description. It's pretty easy. So 100 minus 40, so we can use these numbers. 100 minus 40 compared to 6 minus 2. That's 60 divided by 4, and we just did this. And that is equal to $15 per hour. So notice the equation then is y minus 40 compared to x minus 2 equals 15. Now, if we just went up here and just drew one tiny slope triangle, so for 1 unit, that's the unit change, or that's the unit rate, or the rate of change. If it's 1 hour, you make, or Andre makes $15. Now, what if we wrote the equation from this triangle? What would we have to do? Now, it just is the same thing. Just think about what's going to happen. We're going to take this triangle and we're going to slide it over 8 hours over here. So we're going to get this point right here, and we have to get rid of these 8 hours, and it's going to slide all the way over here. So this horizontal, the number of units in the horizontal direction, is going to be x minus 8. We have to get rid of these 8 hours. Well, what about the vertical direction? What do you have to get rid of? That's moving this down vertically to the horizontal axis. Well, you have to get rid of this $130. So that's going to be y minus 130. So hopefully you're starting to see this. And I want to do this so you see it right next to the problem that we did down here. It's the same steps, the same idea, the same thinking. And so what is this equal to? Well, the number of units in the vertical direction is 15 times the number of units in the horizontal direction. That's why it's 15 times that 1 hour is $15. So that is the slope. It's 15. So this is one equation. This is the second equation down here. And so now what I'm going to do is show you that they are the same. And so we're going to zoom way ahead, well, not way ahead, but ahead a little bit. You're going to start doing this kind of algebra. And don't worry about it right now. Just kind of look at what's going on and see if you can take it in and understand it. The top slope triangle, the tiny slope triangle, was y minus 130 compared to x minus 8. That equals 15. So you can imagine that slope triangle sliding down 130 units and sliding to the left 8 units. And in a similar manner, the larger slope triangle was y minus 40. So imagine that sliding down 40 units and sliding to the left 2 units. Both of these equal the slope, equal 15. All right, so now we're going to go through a little bit of algebra. So if you say this in words, and we tried this a while ago where you just say it in words and it tells you what to do mathematically. Y minus 130 is 15 times x minus 8. So y minus 130, that value is 15 times this x minus 8. So now you can just write that. Y minus 30 is equal to 15 times x minus 8. Same thing down here. Y minus 40 is 15 times x minus 2. So the number of units in the vertical direction is 15 times the number of units in the horizontal direction. So then you can write y minus 40 equals 15 times x minus 2. All right, so now we're going to do a little bit of algebra, and I'm actually taking some shortcuts, things that I would not teach you to do, things that you would eventually just learn to do because it's a simpler way, but it's not the way to learn to do it in the beginning. So I'm not going to say it to you. I'm just using some shortcuts, and you're going to learn how to do this algebra. So y minus 130 is equal to 15x. So there's the 15x right there. And you have to subtract 120. I'm not going to tell you. It's actually 15 times 8, but I'm just going to say that you have to subtract that 120. And in a similar way down here, it's y minus 40 is equal to 15x. So it's 15 times that x. But then you have to subtract 30. So notice it's 2 times 15, but you have to subtract it. So you have to subtract 30. All right, so a little bit more algebra. If you take that 130 away to get the y coordinate, now we're not talking about the number of units in the y direction. We're talking about actually for that point, what is the y coordinate? You have to add that 130 back. So that is equal to, y is equal to 15x plus 10. You're going to add 130 back. You have to add that 130 over here. 130 minus 120. If you're subtracting 120 from 130, you end up with a positive 10. If you're subtracting 30 from 40, you end up with a positive 10. So notice these are both the same. Now look, the unit rate is the slope. That's right here. That's the 15x. It's in both equations. Both equations are the same. And notice that you add 10. That's the starting point. So those are going to become important later, but at least you're starting to see where they come from. It's not a mystery. And we'll do this quite a bit. It's kind of fun, actually. All right, so that's the summary for Lesson 5.